Okay, so here we have an ACT type of question that we're going to go over. Now, the difference between this and what we have been doing is typically we have been given what our angle measure is. So we know that this is sine of 30, sine of 45, something along those lines. But now they're doing the opposite. Now they are telling us, hey, here are two of the side lengths of a triangle, and you need to figure out what some other trig function it would be. Okay, so sine theta is 4 over 5. They want to know what is your tangent theta. Okay, so just like before, the first step that we're going to do is we are going to draw our coordinate plane. Now, since we don't know an angle, I don't know where I need to draw this triangle at. So what that means is you are going to have an additional piece of information. And the additional piece of information that they typically give you is this right here. So we've got 0 less than theta less than pi over 2. And what that means is your theta, or your angle, is between 0 and pi over 2. Okay? Now, that's in radians. In degrees, that is saying that your angle is between 0 degrees and 90 degrees. So that means that this is the quadrant that I am working in. Okay? Now, since I don't know what my angle is, it's not as important to make sure that you draw a 60 degree or a 45 degree. So we're just going to kind of draw a triangle here. We always draw it down with the x-axis. And this is our angle that we're looking at. And that angle is theta. We don't know what any of the other angles are. I do know that that angle is 90 because of how I've drawn it. Okay. And what else that I know about this is I know that my hypotenuse is opposite my 90 degree angle. I know that opposite is opposite of my angle, which means that this is adjacent. Okay. So I've drawn my triangle, and I really don't have any other information. So let's look back at our question. We have this part here with our theta, but the other thing that they gave us is that sine theta is 4 over 5. So we know that sine theta is 4 over 5. So what does sine tell us? Well, we want to remember our trig, the fun little saying. So, ka, toa. Okay. So my sine is my opposite over my hypotenuse. Okay. So what they've given me is they've told me, hey, your opposite side is going to be 4. So this side here, the opposite of 4. And my hypotenuse is 5. So my hypotenuse is 5. Now, up until this point, we've been using 30, 60, 90, and 45, 45, 90 triangles. But if you guys remember back to that very first lesson, 9-3 part 1 video, we also talked about things called Pythagorean triples. And one of the Pythagorean triples that we learned was the 3, 4, 5 triangle. Okay, so our adjacent side for this case has to be 3. Okay, if you don't remember that, you can always use your Pythagorean theorem to figure out what that missing side would be. So say we didn't remember it. I know that my hypotenuse is 5, so 5 squared equals, one of my legs is 4, so 4 squared plus b squared. 4 squared is 16 plus b squared equals 25. Subtract 16, I get b squared equals 9. Square root of both sides, and b equals 3. So you can always use your Pythagorean theorem if you can't remember the 3, 4, 5 triangle, but it is quicker if you can just remember your 3, 4, 5. Okay? So we have our triangle up here. Hypotenuse is 5. Opposite is 4, and that was given to us by this statement right here. And then the last thing that we need to do is they want to know, hey, what is tangent theta? So tangent theta equals, well, tangent tells me that I want to know opposite over adjacent. So my opposite side is 4, and my adjacent side is 3. So 4/3 is the correct answer. I guess I should have mentioned too, I know that this is a positive 3 because I'm moving to the right. I know that this is a positive 4 because I'm moving up. Okay, so that is the type of question that that you will most likely see on the ACT. I've seen it on quite a few of them, so that's why I wanted to throw this in here for you guys. You've got another one here, and this is actually multiple choice, just like the ACT. So we've got sine theta equals 3/5, and pi over 2 is less than theta, which is less than pi. What is cosine of theta? I want you guys to pause this video and try it on your own. Okay, if you got the answer of B, you are incorrect. However, you just made one minor mistake. So if you got the answer of B, you just made one little mistake because the correct answer on the ACT would be negative 4/5. Okay, so let's run through and make sure we know why that happened. We're going to start out by drawing our coordinate plane. Okay, and they changed it up a little bit on us this time. This time they said pi over 2 is less than theta, which is less than pi. So this is between, my angle is between pi over 2 and pi. Okay? Now if you do your conversions, your pi over 2 is 90 degrees and your pi is 180 degrees. Okay? So now our angle is somewhere in this quadrant, which is where those negatives are going to come into play. Okay? And again, I don't know what this triangle looks like, or I don't know what this angle looks like, so I'm just going to draw out, label my theta. We always go down to the x-axis. Okay? Again, they tell me sine is 3/5. So, TOA. Okay? So I need to identify then, this is my opposite, 90-degree angle here, so this is my hypotenuse. Whoops, meant to draw that in red. This is my hypotenuse, which leaves this to be my adjacent. Okay, and we are given that sine theta is 3/5. Sine is opposite over hypotenuse, so my opposite side is 3, and my hypotenuse is 5. So what does my A need to be? Well, again, you can do your Pythagorean theorem if you want. 3 squared plus b squared equals 5 squared. Okay, and when you work that down, you're going to find that B equals 4, and that is because this is a 3, 4, 5 triangle. Okay, however, this is not a positive 4 because I am moving to the left, and when I move to the left, that makes that negative. Is that a positive 3? Yes, because as I'm moving up, that stays positive. So we have a negative 4 and a positive 3. And remember, your hypotenuse is always positive. Okay? So they want to know, what is cosine of theta? Well, cosine is adjacent over hypotenuse. My adjacent side is negative 4. My hypotenuse is 5. Okay? So negative 4/5 would be my answer, and that is why C is correct and not B. If you got B, all you did was you forgot about your negative. Okay? I believe that we have 2 more problems here. So again, pause the video, try these last 2 problems, see how you guys do on them. Maybe we have 2 more problems. Okay, I guess this is just the last problem then? Okay, no, we still have 2 more problems. My board just wasn't working. Okay, so pause the video, try this one on your own. Okay, hopefully you guys have paused the video and tried this on your own. 180 degrees and 270, so that means I am down in this segment here. Okay, again, we don't know exactly where it is. We always draw it up to the x-axis. So here is my theta. Okay, and I am given that tangent theta is 5/12. Okay, well, tangent is opposite over adjacent. Okay, so opposite, this is my hypotenuse, this is my adjacent. So my 5 is the opposite side, my adjacent is the 12. Okay, I need to find what my hypotenuse is. Okay, if you want to find your hypotenuse, you can remember this is a special triangle. You can also do 5 squared plus 12 squared equals c squared. Okay, so 25 plus 144 equals c squared. 169 equals c squared. and C equals 13. So this is a 5, 12, 13 triangle. 5, 12, 13 triangle. Now, are any of these negatives? Well, for my 12, I am moving to the left, so that would be a negative 12. And for my 5, I am moving down, so that would also be a negative 5. Remember, your hypotenuse, though, is never negative. Your hypotenuse is never negative. Okay. Cosecant. Okay, well, this is where we want to remember what the opposites are for these. Remember, your cos can never match up. Cotangent is going to be opposite of tangent. Okay, and then I got cosecant and secant. Well, you cannot have another co with another co, so secant has to go with cosine, and cosecant goes with sine. So your cosecant is just the opposite of sine. Not the opposite, sorry, is the reciprocal of sine. So instead of opposite over hypotenuse, cosecant is hypotenuse over opposite. Okay, so my hypotenuse is 13. My opposite is negative 5. So your answer is negative 13 over 5. Okay, one more. Again, if you have not paused the video, please pause it and try it on your own. I'm going to try to click to that next slide. So again, make sure you guys have paused this and tried it on your own. Drawing our coordinate plane here, pi, theta, 3 pi over 2. So that is again saying that this is between 180 degrees and 270 degrees. Okay, so we are again down in this quadrant here. Okay, for this one, drawing, I always have to go back to the x-axis. So here is my theta, which means that this side would be opposite. This side here would be my hypotenuse, and this is my adjacent. Now they've given me that the cosecant is negative 2. The cosecant is negative 2. So cosecant, again, that's opposite of sine. So that's hypotenuse over opposite. Well, this is not a fraction, but I can turn this into a fraction by putting it over 1. So we have a negative 2 over 1. Okay, so your hypotenuse is 2, and your opposite is 1. Now, how did it become a negative 2? Well, that is because this is moving down, which means that that has to be negative. And I know that that 2 is positive because your hypotenuse can never be negative. Okay? So then what is our adjacent? 2 and negative 1. That's not one of those special ones that we went over. Okay? Or is it? What if this was a 30, 60, 90? So we had 1, 2. Well, 30, 60, 90 means that that side here, my adjacent, needs to be a square root of 3. It, though, is not a positive because I am moving to the left, which makes this a negative square root of 3. Okay? So, we end up with a negative square root of 3. And again, you can always negative 1 squared plus b squared equals 2 squared. That gives me 1 plus b squared equals 4. Subtract my 1. B squared equals 3. Square root, and I get that b is square root of 3. So you can always just do the Pythagorean theorem if you do not recognize it. Okay? But finishing this thing off, tangent, that would be our TOA part. So opposite over adjacent. Okay, your opposite side is negative 1. Your adjacent side is negative square root of 3. Couple things I can do with this. 2 negatives, those would just cancel each other out. I need to get rid of the square root of 3. So I multiply by the square root of 3. Gives me square root of 3 over the square root of 9, which is square root of 3 over 3. So your answer for that one there is just your square root of 3 over 3. And again, those are just some practice ACT type problems. We will work on those more next time in class.